My name's David Anstiss, and I am a Senior Solutions Architect with SS8. I've been in the industry for about 22 years. I've worked for Vodafone, Ericsson, and a lot of communication in those times. And I specialised in radio access networks, core network technologies, and then we were focused on mobile packet core, location technologies, and deep packet inspection. I've worked for SS8 for about 6 years now, and I lead the solution engineering capabilities in EMEA and APAC. So that's kind of a little bit about me and where I'm coming from for this stuff today. So what I'm going to talk about in the agenda, and I'm quite conscious of time and wanting to get through a fair bit of material with you guys today. I'm going to give you a bit of an overview of what lawful interception and lawful intelligence is and what we do as a business. I'm going to sort of talk about the changing needs from law enforcement and some of those change drivers that 5G and other technologies have brought into place, and how we're scaling and moving the business forward. Also, I've created a slide on horizon scanning. So this is something that we do as a business, and we sort of take a 5 to 10 year view of the future of technology enablers and how that's going to impact LI and what we're going to actually implement in our technology moving forward. Then I'm going to talk to you a bit about encryption, some stuff about 5GC and IMSI grabbers and how subscriber identification has been put in place with 5G and how we're actually mitigating that risk in certain countries now. I'm also going to give you guys a bit of a sort of a taster from the law enforcement community, where we talk about different user cases of encrypted traffic and the fact that certain metadata isn't encrypted and how we can actually exploit that. And I'm going to give you an example with WhatsApp, because that's always a very popular one throughout the community, where people say, yeah, I've got a WhatsApp session, but what can you tell me? And so I'll talk you through a bit of that. Then I'm going to spend a little bit of time on 5G location, and I'll talk you through some of the great strides that 5G locations bring into the community and how we're actually exploiting them and how we're moving the technology forward for that visualization capability. Finally, I'll leave about 5 minutes for questions. If I bored everybody to tears and there's no questions, I've got some other stuff I can talk to you about 5G and some of the stuff we found around. Okay, so let's make a quick start. Okay, so what is lawful intelligence? So lawful intelligence from a company like SS8 falls into two main tranches of work. First of all, we have the CSP side, where we provide capabilities to service providers and telecoms operators to be able to meet their regulatory compliance obligation. This basically means we provide data retention services, so we can store communication data for police to investigate crimes, or you to use as paper records when you're working with your customers as part of billing, mediation, and revenue. We provide mediation capabilities, and that's the interception side of things, whereby we can provision network elements and networks to be able to actually intercept data and calls and everything on the network to be able to target and bring that data and deliver it to the lawful intelligence community. We also provide location intelligence, and this is something that 999 and 911 operators use to be able to locate people. And you can use it in an active or a passive way to be able to poll phones and be able to get very accurate, very latest to the second information about where phones are, to be able to follow them and move them around the network as people are. So that's kind of the CSP side, and I'm going to try and focus a bit towards that today. On the other side of the market, we've got the law enforcement community, which is your traditional monitoring suites, whereby the data that's extracted from networks is given to law enforcement communities, be it agencies or intelligence community, where they can then look into crimes and they can actually investigate what's going on, what's happening with these different things. And it's a proportionate thing. It's all warranted and mandated by judicial oversight and obviously ministerial oversight in the UK as well. So there's a lot of stuff we do there, and it tends to be very significant threats. So threat to life, terror, sexual exploitation of children that would do it. If it's me walking along and dropping a crisp packet, they're not going to warrant a technology interception. But for more serious events, we do have this capability. Now, as a business, we work a lot with the 3GP and ETSI standards, and I'm a member of the bodies, and we do provide input into those to help shape the work we're doing at the moment. So what I'm going to try and do is talk a little bit about the fundamental shifts in technology and how that's actually impacting services, and how we're moving to cloud-based services and edge computing, and how we're offering API gateways to be able to use best-in-breed technologies. And I'll try and fit that into the revolution discussion that we've got going here for the community. So let's have a little look at how the product's evolved and the drivers behind it. So even 10 years ago, basic interception was voice, SMS, some data services, be it mobile messaging, be it web, be it email. But the encryption wasn't there as heavily as it is now. So you used to have a traditional over-the-shoulder view. You could see what people were doing when they're on warrant, and you could extract that data. But as changes have come in for over-the-top application use, such as WhatsApp, Signal, and the like, people are using more and more devices. So before, people would have a mobile phone, it went everywhere with them. Now they've got smartwatches, they've got vehicles, they've got different telematics and the like. And these data sources need to be ingested and enriched with other areas of technology. And this means that we're having to cast the net that bit further. We're having to track more devices, we're getting more data. And when you consider the sheer vast quantities of 5G data and IoT communications, we have to use machine learning and other assistants to be able to analyze that big data and analyze that quickly. So one of the things that I'd like to share with you is our horizon scanning and the future of LI technology enablers and where we look at. So there's kind of 6 tranches, and I'll walk you through them. So the first would be enabling technologies. So one of the things in enabling technologies is being able to use other people's key engines to be able to analyze data. So through an API or application programming interface, we would be able to use a voice recognition service to be able to voice print certain people and identify them from the database. There are other technologies, video analytics and the like, but there's certain ethics that you need to be considered of. So for example, SS8 will not sell to certain countries with human rights violations. We will not do mass surveillance of people. We will not use facial recognition. There's certain ethics that we have as a company that we won't actually sell into, and we have turned business down in the past because of those sort of things. The second is combinatorial technologies. So this is where we're looking at machine learning, behavioral forensic, and blockchain. Now, I don't like the term artificial intelligence. I prefer machine learning, and I do see that, and we do have capabilities in that area whereby you can put data in, you can teach a machine to do something, and by putting good data in and got good volumes of data in, you're able to train something to be able to give you some results against big data very quickly. The next step is comms data and mobility technology. Now, this is a really interesting one. Most people, when you talk about scanning and talk about this, just talk about 5G. There's a lot of other stuff going on in the industry, and with IoT and autonomous vehicles, for example. So the telematics we're getting out of vehicles is absolutely incredible. The amount of data and detail that we are seeing in that environment is huge. If you get an Audi or a BMW, you're talking close to 20 connected USIM devices that are all polling out telematics about the engine, about the braking, about the acceleration, the fuel consumption, all this information, and it's vast. And when you give that to an analyst or a policeman that's doing an investigation, he's just swamped. He can't make head nor tail of it. So you need to be able to give some intelligence and actionable intelligence from that and from big data and your analysis thereof. Drones are another one that's quite interesting as well. There's certain ETSI standards around drones and lawful compliance within them, about geofencing them and the like. But also they've been used by bad actors in espionage cases, whereby they'll follow policemen home from police stations and stuff. So there's quite a lot of bad use cases as much as there are good cases. So to be able to intercept drones and manage that sort of capability is another thing at the forefront. The other two I'll touch on in this field is Bluetooth communications, Bluetooth 5. Now, Bluetooth was always the thing that you connected your mouse or your headphones to your mobile phone or whatever. But Bluetooth 5 actually gives you quite a high data rate. It gives you 2 megabytes per second. So that's actually quite fast. So that connection could actually be used for a Wi-Fi hotspot. It could be used to transmit data backwards and forwards, and it can be exploited when you're trying to get intelligence from a device. The final one I'll touch on is near-field communication. NFC is the ability to basically make transactions with a device. So, for example, my credit card, if I go on the tube or if I want to pay for goods, I can tap on or tap off with that. And that is another area of exploitation. When we're seeing criminality, whereby people will go on tube with a scanner and basically skim all the cards as they walk down and ping £30 on each one. If you've got 500 people at rush hour on a tube, you only have to walk down the tube station once and you go to the next one. So we're seeing that exploitation. Next, personal data and wearables. Now, we're seeing quite a lot around this. And as I say, this is like a 5 to 10 year vision, but wearables are actually being used more and more. I was speaking to the guy that actually led an Australian operation, which was the first of its kind in Australia, whereby a wearable device, an Apple smartwatch, proved a murder. The wife had come home and the husband had said that he'd not seen her and she'd not returned home. The watch proved that she'd logged into the home Wi-Fi when she returned home. Secondly, it showed her heartbeat and all the biometrics associated with that. So there was an increase in heart rate where they started to argue, and then it peaked and flatlined. And not funny, but the sort of like black humor slightly was. But then the pedometer kept moving, where he rolled her up in the carpet and walked her out and put her in the car. So they're actually able to prove the whole of the crime scene purely by the wearable and actually prosecute the husband based on that technology. There's other stuff around biometrics and smartwatches, but I'll touch on that later. So data modeling and analysis, this is where the big data comes in and visualizing of the data. And this is one of the things where the old monolithic architectures that we've used in the past for this technology has to move to cloud native. Now, as a company, we've pushed this and we've done a microservices-based architecture with Cassandra databases and Elastic indexing and Kafka communication and these API gateways. So there's a big push there. We've also used Kubernetes and Docker containers for our CNF to be able to orchestrate with Helm charts how to orchestrate these services, because that is the way that the future is bringing the technology. The final part is on the core infrastructure, and I know I've recorded it here as platform as a service. What we're seeing more is SaaS models coming out. People aren't they're wanting to buy software as a service as opposed to buying a perpetual license and then paying support each year. So that's another thing we're seeing. Cloud computing and edge technologies. Yep, we'll talk a little bit about those as well. But the one that I will talk about here is there's another attack vector. So one of the things that cloud computing offers is state-sponsored actors, the ability to attack networks in different ways that they've never had before. So there is more of a drive about encryption, and that leads me nicely into the next section. We have to be very mindful that our encryption at both transit and rest is paramount. And there's certain things with 5G that's encouraged. Before, certain network vendors wouldn't encrypt all of the data they sent to us when they were doing targeted interception. 5G mandates that an IPsec tunnel must be established. There is a zero trust policy before we can even start to provision target and warrant information to those things. So anyway, I think I've talked enough about horizon scanning and the LI futures. And as I say, if there's any questions, please pop them in the box and we can have a chat at the end in the questions section. So what is the impact of encryption? So I'm going to talk about two parts here with encryption. First of all, I'm going to talk a bit about subscriber identification and IMSI grabbers and the impact that a 5GC or a 5G core network, a true 5G core network, is having on the SUPI-SUKI correlation and some of the work we're doing to actually mitigate that, and we're deploying in the Americas market at the moment. The second thing I'm going to talk about, which might be of interest to people, is going to be about WhatsApp and about what metadata is available and how you can build a picture and pattern of life from encrypted communication. Okay, so impact of 5GC on subscribers. So at the moment, we have something in the world called IMSI grabbers. Now, this is used by law enforcement. It's also used by certain nefarious people at Black Hat and certain other conferences. And what it does is it replicates a cell site. And the idea of it is that the law enforcement use it to identify either local devices in a region. They're set up. They know that there's a phone that's belonging to a suspect of interest or a terror suspect, and they can follow him around. And by setting up the cell site simulator, they replicate the network. All the phones in the local area will register on it and basically identify themselves using something called an IMSI, an individual mobile subscriber identity. That can then be used. And if you follow somebody around long enough, now these cell site simulators can be in backpacks, they can be very low power, or they can be in vans. You can follow that person around, and by a process of identification, you can sort of identify his IMSI by going to multiple cell sector sites to be able to find it. The other thing that IMSI captures are very good at is locating devices. So if I know my target and I know he's in a 400-meter range of a shopping centre, I can set this up, or I can set up multiple devices at different areas to triangulate where he is within the cell site, so that I can actually identify him or get a face to a name for that particular person. Now, as we move forward into 5G, 5G was very clever because they wanted to have a zero trust on this. So it removed the ability for cell site simulators to replicate this. So what they do is transmit something called a SUPI. So it's a subscriber identity that is completely is effectively IMSI, but it's a one-use thing. It's never the same each time. And that SUPI is never transmitted. It's always something called a SUKI that's transmitted over the internet, over the air interface. And that is a temporary identifier that changes every time. So there's no way to actually acknowledge and locate the person based on this SUKI identification. So the way that you can look to do it is to correlate the SUPI and SUKI correlation. Now that is something that's not done at the moment in network elements. And there's two trains of thought. There's the 3GPP method, which we're implementing in the US, where we're providing a grey box solution that actually takes in the information and does the correlation and stores it for a set period of time to release to the agencies. And then there's the ETSI methodology, whereby the network equipment provider, the Ericssons, the Nokias and such, are actually developing and storing and providing this capability. Now, the challenge is with that, it's a long-term view. It's a 12 to 18-month release cycle on that. It's not a priority to them. And the challenge we have is certain countries in Latin America and North America are holding up the rollout of 5G technology purely because this capability is not there. So this grey box solution that we're implementing in the Americas is actually really going down well. Okay, so now for a slightly different tack. This is more of a use case that I would talk to law enforcement officials about and the LEA customers. So when you're monitoring a device, you get your traditional voice and your SMS and MMS, and you can reconstruct, all of those stuff. You can play back the voice calls, you can listen to stuff. You can see the images, people browsing the internet. If anything's in clear, you can reconstruct it. If I send a picture message, that picture message will come through in the clear as well. So everything there was fine. As more and more encrypted applications come on, the ability to identify the traffic type gets more and more hard. So you have to use certain other technology and tools at your disposal to be able to do them. So one of the things that you can do is, using the Cloud Act, you can request certain data, certain keys, certain things to be able to decrypt and analyze the data. You can seize suspects' phones, and providing you can unlock them, you're able to actually analyze the content and utilize the keys to be able to read what's gone on and retrospectively. Now, they're very good methods, but they are not always open to people. So one of the big questions we get asked within the industry and within the terms is, what can you do with WhatsApp? It's the biggest, so WhatsApp, as everybody knows, is a over-the-top messaging communication app provided by Meta. Now it provides voice calling, video calling, messages, picture messaging and the like. And it's a sort of a free service that you can use. But there are some key facts that I'll go through with you on it. Now, first of all, it is end-to-end encrypted. So, and I am a big advocate of encryption. I think it is a very well-placed thing, and I think it should be there to protect society. But I also am a big advocate of lawful access to data. So to be able to stop very serious crimes and to be able to investigate very serious matters, I think that's a fundamentally important thing to do. Now, WhatsApp itself does not encrypt local cloud backups, and that's a fundamental thing to know. Same is true with Apple, same is true with a lot of other people, Google. So there are ways and means you can access data. They do not encrypt the metadata. Now, this is a key point, and I'm going to show you in the next slide how you can exploit that. You've also got log timestamps and IP addresses. So the key thing here is that you're actually able to identify, and you're able to build a picture of these people using that. I mean, things like Zalo, when you change your profile picture, one of the things we notice is it's in HTTP clear. So we even get the profile pictures as people change them. So there's some really cool stuff there. So let's talk you through what happens with a WhatsApp message and how that works and what we can actually do with that. So if user A wants to send user B a message, they download a key, a public key for user B. They encrypt using that key, and then when they transmit the message, only the private key, only known to user B, can decrypt the message. It's a simple 101. This is how we encrypt it, and that is completely end-to-end encryption. There's nothing we can do about that. That's great. But there is metadata that you can look at. We can see the source ports and IP. We can get location data for user A, or our target. We can see the throughput. We can see the data sent. We can see the protocols used. We can see the DNS. We can see the direction of the data, uplink and downlink. And you can actually find a lot from that. Now, I had the privilege of working in the industry for 22 years. I've done a lot of training, I've done a lot of education, and I can sit down in front of my computer, and I did a worked example of this with one of our services guys, whereby we captured the data in the system, we analyzed the data, so you could see the UDP packets going, you could see where the B party was, you could see all the information that was there, and based on that, you could actually do a pattern analysis. So our solution would actually classify it as WhatsApp traffic, but by teaching the enabled analytics a bit more, you can actually classify WhatsApp traffic as a text message, a picture message, a voice call, or a video call. And one of the interesting things that people don't tend to know about WhatsApp is, if you make a call, there is something called a stun binding request. So basically, there's a peer-to-peer connection between user A and user B, and these two phones start talking to each other. Now, what you capture is the B party IP address and port number. Now, that to an investigator is an incredibly important and valuable tool. So one of the things you can then do is enrich the data with CDRs. So I could say, right, okay, I've got this IP address and port. It's probably NATed, i.e. it's a public IP address. I'm going to go to Vodafone, and I'm going to say to Vodafone, right, who had that IP at that time? And chances are they'll be able to tell me it was David Anstiss. This is his subscriber details. This is his Minston, his IMSI, his IMEI. And these are the CDR records for David when he was on the call. And we can say that he was in West London at the time. So it allows us to put a lot more granular data down. It also gives you a pattern of life. And that gives you the whom they're communicating with, when they're communicating with, and for how long they are communicating. So it's a really interesting way of looking at things. And this is all encrypted. So I can't tell you what they're saying, but I can tell you who they're talking to and what they're doing. As I say, this is just one example of encrypted communications and how you can exploit the unencrypted metadata. Okay. So let's talk a little bit about 5G location. So as I say, 5G location is, and I'm conscious I want to leave some time for questions at the end. So currently, when we're talking about location, we have something called an X and a Y. So we have a latitude and a longitude, and the cell site is given and it's plotted in a certain area. Now it can be enhanced. We can put RSSI power, and we can say, right, we believe in this band within the cell site, this is where the phone's actually located, which is absolutely fantastic. But it doesn't give a very granular picture. And this can be used with 999 operators or E911, and it can be used for intelligence gathering services. Now, one of the things that 5G introduces is the Z-axis. So this basically gives us an angle of ascent. Now, in previous radio access technologies, we've had the capability to have building penetration with 900 megahertz and equal 1800 megahertz spectrums. With the gigahertz range, you get a lot faster data, but you don't get the building penetration. So that means you've got to have more cell towers, more cell sectors, and denser cellular networks to be able to deploy these things. The other thing that you'll find is that the MIMO technology, which I'll talk about very quickly, allows you to actually find an angle of ascent, and that's a really, really powerful tool. Now, the accuracy, minimum accuracy, 50 meters, 10 meters, 3 meters, we're actually seeing it a bit higher than that. We're talking decimeter level, i.e. within 10 centimeters is the positioning we're getting, which is fundamental for connected vehicles. So there's 5 real key things that we'll talk about in the next few slides, and they are the different ways we can position people, be it with round trip times, with the angle of ascent and angle of arrival, and we could also talk about the positioning referencing system as well. So I'll just skip through some of these. So the first one we can talk about is time of arrival. So by anchoring different node Bs, we know a fixed geolocation. With the very, very small latency that we get, i.e. microsecond timestamps, we're able to position people very, very accurately. And when you start getting multiple cell towers, it gives you the ability to actually position somebody and how far they are away based on that difference of arrival time. The second thing that we can use is a 4G technology that's been enhanced into 5G. And that basically puts a grid reference system down on a network and allows for multiplexing of technologies for packet data sharing and the like. So i.e. one node B wouldn't be loaded, it could load balance across them. But again, this gives us the ability to position where that person is within that grid. And again, it helps us when we're locating people. The final thing I'll talk a little bit about, the penultimate thing I'll talk about here, is about 5G and multi-cell based positioning. So this is about round trip time, and this is similar to time in advance. So if you have done any work in 3G or 4G, you can actually measure the time of arrival versus the round trip time, and you can calculate, as long as they're on an active warrant, you can actually calculate the direction of travel, and you can get an indicative travel speed based on the fact that you're getting these timing movements. So you're actually able to ping the phone every few seconds and get that very granular information as to where they are, where they're moving to, and sort of an indication of if they're fixed or if they're moving and how fast that is. Now, the most interesting one is actually this, which is the angle of departure. Now, with the MIMO technology, it actually uses like a headlight to sort of shine out of the cell tower, for want of a better word. And that allows us to calculate an angle of arrival or an angle of departure. And that allows us to put people in different, for example, floors of buildings. In this instance, it would be the second floor. Now, there is some problems with, or some challenges with this. There is a small plus and minus, i.e. one floor would be about correct. So we would say they're on the second floor, but they might be on the first or the third. And it would depend on certain technologies. Also, with the gigahertz spectrum, you'll also find that the person, when moving about within a building, can be misconstrued, i.e. they could be closer to, if they're next to a window, they might appear one place. If they're behind a wall, they might appear further away. So there's certain measurements that go on there. But for the most part, as I say, we're seeing decimeter level. Now, the reason I mentioned this, and I know I've gone a bit quick over this section, the reason I mentioned this, one of the things this allows us to do is now stop mapping in 2D and start mapping in 3D. So we're actually able to give agencies and intelligence officers the ability to position people in buildings as opposed to in a generic area of a location, which is a real game changer for us. So I'm 3 minutes, and I guess I'll open it up for questions. I believe there's one in the Q&A section now, so I'll just quickly grab that. So, okay. So, would you consider facial recognition more invasive than speaker recognition? Yes, it'd be the honest truth to that. So when you work with the banking sector, there are certain exploits to facial recognition. I won't go into too much detail, but there are some very abusive user cases for facial recognition. With voice recognition, we do find that more intuitive, and we can see more benefit to that. It's a good question, but yeah. With banking apps, if you phone up and say, hello, my voice is my thing. Yeah, voice recognition, we're more privy to, but yeah, facial, not so much. Okay, Annie, sorry, I think I'm more or less on time there.
I think you're right on time. So, David, thank you very much. Perfectly timed. And as ever, a fascinating look into an area maybe not many of us know that much about. So thank you very much indeed.
You're welcome. Thank you again for the time.